Welcome to this tutorial. Uh, the series I'm going to start today with this tutorial is the series in which I am going to solve past papers. I'm going to start solving these past papers from the year 2018, May, June, and the paper we are going to start in this tutorial is paper 1-1, paper 1 and variant 1. As you can see that the duration for this paper is 2 hours and candidates have to answer all the questions on the question paper. Calculators, electronic calculators cannot be used for this paper. Answers are to be written with uh, blue or black pen, dark blue or black pen. Similarly, the geometrical instruments can be used in this paper for assistance, but calculators are not allowed. The total marks for this paper is 80. In this series of tutorials, I will be solving around 5 questions in every video, and it should take around 5 to 10 minutes to solve these questions. And the rest of the questions will be continued in the other videos in the next videos. So I'm going to start question number 1 now. This question is related to numbers, the topic of numbers in our syllabus. And we have to, the question 1 part A says that we have to evaluate this fraction. So in order to evaluate this fraction, we have to simplify uh, first the numerator where 3.5 is written and 1.9 is being subtracted from this. So when we subtract 3 point, we write 3.5 and 1.9 is subtracted from it. So 1 is borrowed from 2, 15 minus 9 is 6. Then we have to write the decimal point beneath it, and then 2 minus 1 is going to give us 1. So 1.6 is going to be the answer of this subtraction, and it is being divided now by 0.8. So in order to perform this division, we will be cancelling the decimal point of the numerator. To cancel the decimal point, just cut the decimal point and write 1 below it, and then you have to write zeros, the number of times the digits are written after the decimal point. So after the decimal point, we can see that only 6 is written. So we are writing here only a single zero. Then we had 0.8. The same way decimal point is cut over here. 1 is written here, and we are writing a single zero with the 1. So after reciprocating, the fraction of the denominator 16 will be multiplied by 10 and 10 will be multiplied by 8. So 10 is cancelled here with this 10 and 8 is going to simplify 16. So the final answer that we are getting for this question and for this part is 2. This is how we evaluate this fraction in the simplest form. If you have any further questions about any question or any solution or any confusion, you can mention that question in the comment section. I will try to answer that also. So now I'm attempting part B. It says evaluate 9 plus 6 divided by 3 minus 4. We have to apply the sequence of operations rule in maths here. So according to that, the division should be performed first. So 6 divided by 3 will give us 2. Then we will be adding these two numbers. So 9 plus 2 will give us 11. And finally, we will be subtracting 4 from 11. So the final answer we are getting here is 7. This is how this evaluation is done according to the rules of BODMAS. Now, question number 2, part A says work out 15% of 80. So in order to solve this question, 15% means 15 upon 100 will be multiplied with 80. And now we are going to simplify it. 0 can be cancelled with this 0. 5 will simplify this 15 and 10. 5 3 is a 15, 5 2 is a 10. And 2 will simplify this 8. So 3 4 is a 12 is the final answer. So 15% of 80 is going to be 12. The next part says work out this form 3 upon 5 minus 2 upon 7. Give your answer as a fraction in its simplest form. So in order to simplify and find a single fraction, the first thing we have to do is to make the denominator same. And in order to make the denominator same, we are going to multiply 5 with 7, and 7 will be multiplied with 5. Similarly, the numerator of the 5 will also get multiplied with 7, and the numerator of 7 will get multiplied with 5. So now we have a new set of fractions here, where 3 sevens is 21 and the denominator is 35. Then minus, we have 2 fives are 10 and 7 fives are 35 over here. Since the denominators are same, so now we can work out these fractions by taking LCM, and the numerators will be 21 minus 10. So the answer is 11 upon 35, which is the most simplified form and the answer of this question. Next question says, write these numbers in order of size starting with the smallest. So in order to find out the smallest number, we should write here these numbers in the decimal form so that we can find out the smallest number easily. So 1 upon 3 is going to give us 0.33. Then the next number is written 0.32. And then this fraction can be simplified in 3 upon 8. And 3 upon 8, if we divide 3 by 8, it can give us the decimal form. So for dividing, we are going to use here the decimal point. 8 3s are 24. It gives 6 as the remainder. Then we are going to use another 0 here. And by writing this 0 with 6, it will become 60. So 8 7s are 56. So we have 4 remainder here. So the answer for this fraction becomes 0.37. And then the next number is 0.3, which can be written as 0.30. And similarly, if we divide 9 by 31, we will be using a decimal point, which will make it 90. So we will be using 2 here. 31 to the 62. Answer is 28. And again, if we want to divide it, we will be using another 0. It will make it 280. And the answer is going to be 279. And the remainder is 1. So the equivalent decimal point for this fraction is 0.29. So after writing all the numbers in decimal form, we can easily work out the smallest fraction and the smallest number. So the first number that we should write here in the first place by starting the smallest one is 9 upon 31. Then the second number should be written 0.3. The third is going to be 0.32. The next one should be 1 upon 3. And the last one should be 15 upon 40. So this is how we can arrange the numbers, the given numbers, starting from the smallest and ending with the biggest number. The next question says, the diagram shows part of a shape which is symmetrical about the line L. So the line L is the line of symmetry for this shape, which is obviously incomplete here. What we have to do is that complete the shape. So the shape should be completed in a way that it should remain, the line L should remain the line of symmetry for this figure. So for completing this shape, first part I'm drawing is this one, and then by looking at the next part, I'm drawing this part. So you can see that the similarity is still maintained over here. And then we have to draw this part, uh, which takes two boxes and goes through these two boxes as a diagonal. And finally, the last portion will be drawn. Uh, it will be a horizontal part which will connect this figure. So this is how the diagram is completed. And you can see that the diagram is still symmetric about this line L, and the line is still the line of symmetry for this question. Okay, the next part says the diagram shows part of a shape which has a rotational symmetry of order 2. What is the rotational symmetry of order 2? It means that if this figure is rotated clockwise or anti-clockwise through a complete rotation, which is going to be 360 degrees, the shape will take its original shape during this rotation two times. If the shape takes its original shape two times during one complete rotation or 360-degree turn, then the rotational symmetry of the figure is 2. We should remember that every figure takes at least once its original shape in this 360-degree rotation. At the end of the rotation, every figure is going to return to its original shape. But before that, if a shape returns to its original shape at least once before 360-degree angle, then the rotational symmetry of the figure becomes 2. And if it takes more than once, then similarly, it can be the rotational symmetry can be 3 times or 4 times or any other number. Now, in order to complete this shape so that it takes rotational symmetry of 2, I am going to draw a line over here first. It goes to this box in a vertical way. Then a horizontal portion will be drawn over here. And then we are going to draw a line which is going to come down three boxes. And the line would seem to be a diagonal for these boxes. And then there is going to be a horizontal portion of the figure. So now this figure can take the rotational symmetry of order 2, as I will be showing you in a software that when we rotate this figure in a 360-degree, it will um, take its original shape two times, so it has the rotational symmetry of order 2. So in order to show that how this figure has the rotational symmetry of order 2, I'm going to take help of a software which is GeoGebra. I have pasted the image here. Now I'm going to rotate this object through a complete rotation of 360 degrees. And the thing that we have to note over here is that how many times the image or the figure takes its original shape during this 360-degree rotation. Now, as you can see that the object is rotating, and here at around 180 degrees centigrade, the object has taken its original shape. And as we go further, the object will again take its original shape at 360 degrees. So this is how the rotational symmetry of this object can be observed, that it takes its original shape twice during this 360-degree rotation. Now, the last question that we will be solving in this tutorial is going to be question number 5. It says a plane leaves London on a flight to Dubai. The plane lands in Dubai where the local time is 17:20. The flight time is 6 hours 50 minutes. The local time is Dubai is 3 hours ahead of the local time in London. Calculate the local time in London when the flight left. So the first information that we have is that the plane landed in Dubai at 17 hours 20 minutes, 1700 hours 20 minutes. And the total time that it was flying, the plane was flying, was 6 hours and 50 minutes. So using these two informations, we can find out the time when the plane started flying or it departed from London. In order to find out the time when the plane started flying, we will be first subtracting 50 minutes from this time. So the time that we are going to get is 1630 hours, and then we will be subtracting 600 hours further from this time. So the time that we are going to get is 1030 hours. It means that the flight left London at 1030 hours. The next information that we have is that the local time in Dubai is 3 hours ahead of the local time in London. So the difference of time is 3 hours. So now, finally, what we have to do is calculate the local time in London when the flight left. In order to find the local time of flights leaving, we will be subtracting 300 hours from this time, and the time that we are going to get is 730 hours. So the final answer for this question is 730 hours was the local time in London when the flight left. Part B of the question says, at one time during the flight, the temperature inside the plane was 17 degrees. The temperature outside the plane was 43 minus 43 degrees centigrade. Work out the difference between the inside and outside temperatures. For finding this difference, we will be subtracting one quantity from the other. I am subtracting minus 43 from 17. Since 43 is a negative quantity, so its minus would be written in the brackets, and another minus sign would be written outside the bracket, which shows that we are finding the difference between these two quantities. So the answer is 17 plus 43, which makes it 60. So the difference between the outside temperature and the inside temperature is 60 degrees centigrade. In the next part, it says that the plane leaves London where the temperature outside is 17 degrees centigrade. The plane rises to a height where the temperature outside is minus 43 degrees centigrade. The temperature decreases by 2 degrees centigrade with every increase of 300 meters in height. Calculate the increase in height of the plane. So to find the height of the plane, the first thing that we will be needing here is the difference in temperatures. So we have already worked it out, and the difference between these two temperatures is 6. Now this difference in temperature can be used to work out the height that the plane is taking. Since the temperature decreases 2 degrees with every 300 meters in height, so the first thing that we should do is that we should divide this difference, and the answer we are getting is 30. The temperature would decrease 30 times for 2 degrees centigrade. So now this number, this 30 should be multiplied with the height, and the answer we get is 900 meters. So I hope the things I have explained and the questions I have explained in this tutorial are clear to you. If you have any further questions or queries, you can comment. You can write your question or your confusion in the comment section below. I will try to answer all the queries which are written in the comment section. Secondly, I'm going to continue solving this paper in the next video. I hope to see you in the next video tutorial, where I will be continuing this question paper from question number 6. Thank you very much for watching.